Hello, I'm Elise Corbin. I'm the Conservation Education Coordinator at Peter Francisco Soil and Water Conservation District, serving Buckingham and Cumberland counties. Now we're going to talk about minerals. Minerals are the building blocks of rocks, and geologists have identified 5,000 different minerals. There are 5 conditions that must be met to be a mineral. Number 1, it has to be naturally occurring. It can't be man-made like plastic. 2, it has to be inorganic, which means it's not living. 3, it has to be solid, can't be liquid or gas. 4, it has to have a definite crystal structure. So it's going to be the same for each mineral. The mineral quartz always has a 6-sided crystal. And number 5, it has to have a fixed chemical formula, a specific recipe of elements. Quartz is made of silicon and oxygen, so its recipe would be SiO2. Pyrite, also known as fool's gold, is made of iron and sulfur, so its chemical recipe would be FeS2. Your body needs minerals. Most people get the amount of minerals they eat by eating a wide variety of food, but sometimes it's necessary to take a mineral supplement. Whereas vitamins are organic, that means they're living. They're substances made by plants or animals. Minerals are inorganic elements that come from the soil and water and are absorbed by plants and animals, or eaten by animals. We also absorb minerals in Buckingham and Cumberland County because we have well water and it's pumped up from the ground, and so it's loaded with minerals. And your skin, being the largest organ in your body, every time you take a shower or a bath, you're absorbing minerals from your water. And when you drink it, you're getting minerals from your water. So there are 2 different kinds of minerals, macro minerals and trace minerals. Your body needs larger amounts of macro minerals. They include calcium, phosphorus, magnesium, sodium, potassium, chloride, and sulfur. You only need a small amount of trace minerals, or just a trace of them. They include iron, manganese, copper, iodine, zinc, cobalt, fluoride, and selenium. So, gemstones, like this amethyst, what are they? They're minerals. Minerals that can be cut and polished to make jewelry and other ornaments. The ancient Greeks made a distinction between precious and semi-precious gems, which is still used today. Precious gems were hard, rare, and valuable. Only the precious gemstones are diamond, ruby, sapphire, and emerald. All other quality stones are called semi-precious. And even though they may not be any less valuable or any less beautiful, today mineralogists and gemologists describe stones in technical terms, including their chemical compositions, or their Mohs hardness scale, which we'll talk about in a little bit, and their crystal structure. So the mineral beryl, that's where emeralds and aquamarines come from. The mineral corundum, if it's blue, you're going to get a sapphire. If it's red, you're going to get rubies. And something else. Is a pearl a mineral? No, it's not a gemstone or a mineral. It's made when sand irritates an oyster, causing it to secrete a layer after layer of protection. So pearls were organic. And remember, minerals have to be inorganic. So, what about precious metals? Are they minerals? You bet. Gold is probably the most precious metal. It's dense, but it's soft. And have you ever seen people bite gold in the old movies, maybe the old westerns or something like that, to see if it's real? If it's real, your teeth will leave an impression in the gold. If it's full gold or pyrite, you'll probably break your tooth. And that's what makes you foolish. That's why it was called fool's gold. But also it fooled you, right? Pyrite will leave a black streak on a streak plate. When we do mineral identification, you'll see what streaks I'm talking about. But gold will leave a gold streak on a streak plate. It's one of the most popular, well-known minerals, known for its value and special properties since the earliest of time. Gold in its natural mineral form almost always has traces of silver and may also contain copper and iron. A gold nugget is usually 70 to 95% gold, and the remainder is mostly silver. The color of pure gold is bright yellow, but the greater the silver content, the more white the gold is. Much of gold is mined actually from gold ore rather than from gold specimens. The ore is often brown, iron-stained, rock, or massive with white quartz, and usually contains very small traces of gold. To extract the gold, the ore has to be crushed. Then the gold is separated from the ore by lots of various methods. But gold nuggets are formed when erosion causes a large piece of gold to separate from its mother rock, or the mother lode, and then gets carried into a stream or river. The flowing water tumbles the gold, giving it a round shape. It eventually settles at the bottom of a river because it's a very heavy metal. Gold is one of the heaviest minerals. When it's pure, it has a specific gravity of 19.3. Most minerals have one of about 3. So you can see where it's much, much heavier. So that's what allows it to be panned because of its weight. Gold is also the most malleable and ductile substance known. It can be flattened out to less than 0.0001. 4 zeros, 0.00001 of an inch, and a 1 ounce mass of gold can stretch for a distance of 50 miles. Gold is one of the most resistant metals. It won't tarnish, discolor, crumble, or be affected by most solvents. This adds to its uniqueness and allure. Copper is a mineral that is highly used by humans. So we used to make pennies with it, but over the years we've gotten less copper in our pennies and more other metals. And today it's pretty much just a thin layer of copper over zinc. But copper is used in building constructions, power generation, transmission, electronic products, manufacturing, the production of industrial machinery and transportation vehicles. Copper wiring and plumbing are integral in appliances, heating and cooling systems, telecommunication links, all that social media and everything is powered by copper. It's an essential component in motors, wiring, radiators, connectors, brakes, and bearings used in cars. The average car contains 0.9 of a mile of copper wire. And the total amount of copper ranges from 44 pounds in small cars to 99 pounds in big luxury and hybrid cars. So, in Buckingham County, in Willis Mountain, there is a mineral called kyanite. And Virginia is the only state in the United States that produces this. The mineral has a long, needle-like crystal, and the length of the crystal is softer than a knife blade. But across the crystal, the mineral is harder than a knife blade. The color of the mineral is usually blue, but it may be white, gray, or green. And why is kyanite so important? Because it's a refractory. And a refractory is a material that can withstand very high temperatures. I'm talking about 3,000 degrees Celsius or 5,432 degrees Fahrenheit. It won't break or soften at those high temperatures. And so that makes it useful for ceramics, superalloys, heating insulation for furnaces, for jet and rocket engines, and parts of space vehicles like the space shuttle. So here in Buckingham County, kyanite is found in a metamorphic rock called quartzite. Some other interesting facts about minerals. Quartz is the most common mineral found in the Earth's crust. It's found in all types of rocks, igneous, sedimentary, and metamorphic, and it comes in all different colors. Weather erosion causes it to break into sediment. The particle size of quartz sediment would be sand. Sand then is melted down to become glass. The mineral feldspar breaks down to clay-sized particles. Red slate, quartz, and feldspar sediments primarily make up the soil in Buckingham and Cumberland County area. And you heard red slate, that's what gives our soil its beautiful red color. The mineral galena is where we get lead fishing weights from, and shotgun pellets for all you hunters. It has the perfect box cube form, crystal form. The mineral graphite is pencil lead. Diamonds have only been found in one state in the United States, Arkansas. And diamonds are, remember, a precious gem. The mineral bauxite is aluminum. The mineral sulfur, could smell like rotten eggs. And the mineral fluoride is used to make fluoride toothpaste. We're going to do a mineral identification lab in our next video, but just to let you know how minerals are identified, the first thing is color. The next step that's used to identify them is luster. And luster refers to how the mineral reflects light. It could be metallic, glassy, or vitreous. It could be dull, or it could be resinous, if it's somewhere between glassy and dull. Streak is the color that when you rub the mineral across either a black or white ceramic plate, that's the color that it leaves behind. When we talked about fool's gold, will leave a black streak, but if it's real gold, it'll leave a gold streak. Hardness. Now, this is a difficult concept for many people to grasp because do you know glass is actually harder than a hammer? How can that be? Because in hardness, you're not talking about breaking, bashing, pulverizing, smashing. It's all about the scratch. So glass will scratch the aluminum hammer because glass has a scratch of, there's a hardness scale, 1 being talc and 10 being a diamond. And diamond will scratch glass. It's number 10. But on the scale, let's see, the glass has a hardness of 6.5. So the aluminum on the hammer has a hardness of 3.4. So the glass will scratch the hammer. The aluminum in the hammer will not scratch the glass. So to determine hardness, they use fingernails, which is about 2, a penny, which is about a hardness of a 3, a nail, which is hardness of about a 5.5, a glass plate, which is about 6.5, a streak plate, which is made of porcelain, which is about 7.0. Anyway, the crystal form is always going to be the same for the minerals, so that's another way that scientists identify minerals. Cleavage and fracture, it's the way the mineral breaks, so that's another way that they can help identify minerals. Anyway, that's it for our mineral presentation. If you'd like to do our mineral lab, it's going to be in the next video, and we'll actually identify 2 minerals together.